Good morning, good afternoon, folks. My name is Jagain Sundar, and I'm co-founder of Infant Store. We also have Jitendra Pandey, our other co-founder. The topic for today's webinar is MLflow, an essential service for the modern AI-driven enterprise. Today, we'll talk a little bit about MLflow tracking. Why is it that MLflow is considered an essential service? MLflow tracking is very important. We'll go into details of that. MLflow model registry. This is another aspect of MLflow that is very important for enterprises to adopt and manage. We'll go into the details of that. There are other features in MLflow, such as MLflow projects and MLflow model definitions, which we're not going to address in great detail today, but they're very interesting functionality as well. That's a topic for another day. Finally, we'll go into the requirements for an enterprise-grade MLflow. Now that we've decided MLflow is critical for an AI-driven enterprise, how do you turn this into an enterprise-grade service, and why you should do that, as opposed to each data scientist having a copy of MLflow in their own laptop? Why is this a superior alternative? First off, let's look at some terminology. When I say AI, I mostly mean deep learning neural network models that often use unstructured data. They do use neural network models built on SQL query derived data, structured data as well. But we think that the future of AI is really processing unstructured data, because the world around us is unstructured, and it's exciting to be able to do deep intelligence on that. We'll talk a lot about MLOps. What is MLOps? Essentially, MLOps is DevOps for AI, with specific enhancements and extensions that apply mostly only to AI applications, neural networks. By the way, in case you hadn't known, we're big fans of Python. We think that a lot of machine learning is done in Python and R and such like. DevOps in its traditional form doesn't really address any of the environments that data scientists are fond of. So MLOps is a special purpose DevOps that's highly tuned for machine learning operations. We'll take a look at open source MLflow and its capabilities, of course. This is not a comprehensive overview of all the features of open source MLflow, but we'll look at all the important aspects. And finally, we'll look at Infant Store MLflow, which is a 100% MLflow that has enterprise enhancements that enables you to build an enterprise-grade service out of your open source MLflow. So why MLflow? MLflow has this capability called experiment tracking, which is very important for AI applications. Let's take a look at traditional software engineering. There is a lot of confusion in the industry out there where data science and AI application building, model building is considered similar to or the same as software engineering. That couldn't be further from the truth. The truth is you have wet labs where chemistry experiments, physics experiments are performed and recorded, and new discoveries and inventions are made. The data science aspect of AI is actually more similar to the wet lab experiments that people perform in traditional science than it is to software engineering. Sure, it uses computers and almost all the processing is digital in nature, but the methods are statistical, and often you have similarities to wet lab experience that is missed by some of the modern tools. If you look at software engineering, version tracking is an important aspect of it. Of course, there's bug tracking and there's various different types of tracking. Git is a wonderful tool for revisioning software, monitoring differences between software versions, but this is not actually a useful tool for tracking data science progress, data science experiments, data science runs. What is more useful is something similar to what the wet lab folks are familiar with, lab notebooks. Now, we all know that without a properly recorded experiment, if you are a drug company, for example, the FDA will require you to supply lab notebooks for all the experiments that you provided. If you are a uh, company that is inventing new types of materials, battery technologies, nanotechnologies, whatever, the lab notebook is a critical component of every experiment that you perform. As it turns out, in data science, the AI applications, tracking experiments is an exercise that's very similar to having a lab notebook to track your wet lab experiments. This is where MLflow tracking steps in. MLflow is a fantastic tool for tracking experiments, and it gives you all the facilities that you need to keep a complete record of your own experiment progress. Here's a simple example. Let's say you add 3 lines of code. You're writing an XGBoost program to train a model. You add a line mlflow.xgboost.autolog at the beginning of the experiment. And then before you do your work, you do an mlflow.startrun. That experiment run is logged in your experiment, my XGBoost experiment, for example, and the parameters that you used in your experiment run are logged. The metrics along the way of the run are recorded. If you had any artifacts recorded, those are logged. And if you have models stored, those are also logged. In this screen capture, you can see the detailed view of that particular experiment run. And I can show you a short demo video that demonstrates this purpose. In this video, what we have is a CLI program. And at this point, the CLI, we have set an environment variable, MLflow tracking URI equals infantstore::MLflow.istage4.com. What this does is it points all of the MLflow calls to a service that's hosted in the cloud. The advantage of this, of course, is that if the data scientist's laptop is not available or whatnot, the experiments are still logged and available as part of the service. This is the service that we are discussing in detail today. So we run the program using this command, MLflow run dot. And as you can see, MLflow is just a thin wrapper around the real code that does the work. Training is happening. The log loss is being recorded as a metric, for example, and the run is complete. Now, this, as I mentioned, has been logged in the cloud in the service. And let's go take a look at what the web user interface for this log looks like. It got recorded in the default experiment about 38 seconds ago. As you can see, there are parameters that are logged, there are metrics that are logged, and as we scroll down further, you can see that we've logged the feature importance weight and the JSON value for that as well. We also log the model. This model is actually stored in S3. And in this particular demo, I'm going to show you how you can register the model as a version of a model named Model 3 by Jigane. So this is a very brief view of what capabilities MLflow offers. And it should give you an idea of how easy it is to incorporate MLflow in your day-to-day workflow. There's no extensive work necessary. And from the model, you can go back to look at the run. You can look at the code that was used for the run. You can look at the parameters that were logged and so on. Now, to reiterate, experiment tracking is very important. For data scientists, the ability to track their work and stay organized is critical. Often data science is comprised of experiments in very much unknown territories, new types of algorithms, new types of parameters that applied to those algorithms. They're tweaked constantly. It's very iterative. Having an ability to automatically in the background log these activities gives data scientists the ability to go back and look at some of the experiments they did. It's a critical component of an organized data scientist. Enterprises can build collective knowledge. This is important. Remember, when we talk about an enterprise-wide MLflow as a service, it gives folks the ability to look at work that others have done, subject to permissions and authorization, of course. And once the person has a authorization to view an experiment run or some such, you can go back and look at experiments that others have done, perhaps worked on the same data set that you're going to work on. Another valuable thing for enterprises is if you have data scientists who leave the company to go elsewhere, the work that they did is perfectly recorded. And it's important for continuity. There are often regulatory requirements. The regulatory requirements can come from organizations like the FDA or FINRA for financial applications. Sometimes you may have to prove that you did not deliberately incorporate bias into your model, that it was accidental. You need a full-blown tracking system to make sure that you can indeed prove that. This is critical for the modern AI-driven enterprise. Finally, there's an interesting aspect that's become more and more important these days. For patent protection of some of the inventions that you create using data science experiment, tracking the experimental work that you did, the runs that you did, turns out to be critical. Intellectual property protection is going to become somewhat different in this day and age of AI-driven models, because it isn't like a software patent, or it isn't like a patent for a new invention. This is built using iterative experiments, and in order to prove that you in fact invented this, having a record of the experiments that you performed, the different things that you tried to get and build this new invention is important for you to protect your patents. So that's another reason why a modern AI-driven enterprise must track all the experimental work that's done by the different data scientists. Let's look at the second very important aspect of MLflow, the model registry. This is a system where you can incorporate and share models with other folks in your enterprise, subject to authorization rules, of course. If you have rules that certain group members can view your models, you can do that. And that is very important from the perspective of learning from collective knowledge, using others in work. Other folks in your company may have already done some work that you may want to build on top of. So you have data science experiments that produce models, and the models can be registered with MLflow in the model registry and shared with very fine-grained control. Once the model is registered in the model registry, you can have staging, production, and archived versions of different versions of the model. You can deploy different versions of the model for production, for batch inference, or for live inferences if you have live inferencing requirements. All of this is managed in a very sophisticated manner with the MLflow model registry. So now that we've looked at the two most important aspects of MLflow, what does it take to build an enterprise MLflow? And why do you need an enterprise MLflow? Why not just use open source MLflow? So the open source MLflow library is a fantastic interface and introduction to MLflow, but it doesn't have authentication, authorization built in. Scalability is a question, and there are no considerations given to high availability and disaster recovery. By default, if you were to install the open source MLflow library and start an MLflow run, it would record in a directory in the local laptop that you're running this experiment on. While that's useful for playing with, it really doesn't give you, corporate-wide access, or it doesn't give you access. If you shut the laptop down and go home, you won't have access to that particular experiment or run. So it's basically something to get started with. But in order to make this a corporate-wide effort, you really need to build an enterprise MLflow. Let's take a quick look at all of these features. In order to do that, let's consider the architecture of InferenceStore MLflow service. That'll be very illustrative in giving you an idea of what it takes to build an enterprise MLflow. In our architecture, we use DynamoDB as the store for all MLflow tracking and model registry information. S3, of course, or other cloud object stores are the location where the artifacts themselves may be stored, but information about experiments, information about models, information about who can share what with whom, all the authorization information is stored in DynamoDB. And we have designed the schema for the DynamoDB that we use very intelligently so you can scale extraordinarily high. And I will go into the details of that in just a little bit. All of the functionality of our MLflow service is implemented as REST APIs supported by Lambdas. The scalability and availability characteristics of Lambdas are very interesting to us. Plus, you don't need to have servers running 24/7 providing service. Suppose you have, off office hours. If you had an MLflow system built using MySQL, for example, you would have to size it to the biggest load that you can see. So if you have 100 data scientists running and they need the biggest MySQL instance, you'll end up with the biggest MySQL instance that's running 24/7. As you can imagine, that's a lot of wasted resources. The Lambdas are fronted by the API gateway, and it improves the availability characteristics. We'll go into that in a little bit later. There is also a user interface with some static HTML and JavaScript that has its origin in a S3 bucket, and it has CloudFront in front of it, thereby improving the global availability of that system. Somebody comes into the system with a browser, they will go to the static HTML files, and the static HTML JavaScript files will call REST APIs. That is all taken care of with an authenticated and authorized system. Of course, for direct REST API calls, for example, the CLI MLflow run that I demonstrated a few minutes ago, that calls directly into the REST API. That can go directly to the API gateway and doesn't need to hit the user interface components. Now, while we are on this architecture slide, I'd like to talk about the scalability of our system. So our system has been tested with over 1,500 concurrent users doing all manner of data science activities that floods the service with requests. And the reason that our scalability is so good with very little resources is because our design of the DynamoDB schema is excellent, and Lambdas scale very well for our purpose. As you know, the CloudFront CDN is also scaled worldwide, and availability of that system is excellent. Right, so let's talk about authentication. The open source MLflow library does not include authentication of any kind. And we have included authentication in our service by putting a AWS Cognito authentication system in front. This Cognito system can federate to your enterprise's native authentication system, be it Active Directory, Azure Active Directory, Google OAuth, or Auth0, or one of the other OAuth systems or SAML2 systems. We integrate seamlessly with those. You can use those for your source of truth and actual authentication information. We don't need to manage the passwords for the system. Now, what is authenticated? The web user interface, REST APIs, Python SDK, all other language SDKs, service to service. This is very important. One of the things that you will do in a machine learning activity is run some of your work in a system in the cloud. Now, we have our own solution for that called the Instance Store Compute Engine that can split your work into multiple nodes and run it 10 times faster than running it in a single node. And you don't have to build custom Kubeflow workflows to get that done. But should you have other methods of doing so, maybe you have a set of machines in the cloud that you use for this, you have your own scripts to do that, you still need service to service authentication, and our system does that. We will still authenticate, and you will have the ability to run training sessions that, for example, run for a whole day or 10 hours, 12 hours, that's still fine. Our system takes care of all the details of authentication. So let's take a look at how our authenticated system works. Now, in this example, you can see that I've been redirected to one of two other federated authentication systems. InfinStore Corp is our Azure Active Directory authentication directory, and we can also sign in using Google OAuth. In this example here, I'm going to use InfinStore Corp. I go in and I'm asked to choose an account. This is again Microsoft Azure Active Directory interface, as you can see. And in this example, you can also see that it's forcing me to do two-factor authentication using an authenticator app on my phone. I'm going to type in the code and I will be able to log in to my account, which is now authenticated using our Azure Active Directory database. As you can see now, we have access to the standard MLflow UI and experiments, models, all the capabilities that are present in the system are now accessible after authentication. So authorization. In this particular enhancement that the InfinStore MLflow offers over standard open source MLflow, we protect two resources, the experiment and the model. Now, one mode of operating is to say that experiment space is private. Some of our customers do that, where each data scientist gets his own private namespace for experiments, and they don't share experiments with anybody else. Sharing happens when they generate a model and register the model with the model registry. At that point, authorization kicks in. The other mode of operation is to say that experiment space is shared across members of a group, and you can set that up. We enable you to do that. That gives you the ability for multiple data scientists working on one project to have a shared experiment, but they have their own runs and they can share runs between each other normally, and sharing with a wider enterprise happens by publishing models through the model registry. For our authorization system, we use RBAC, and the roles we have defined are reader, editor, and manager. Now, these roles are configurable. They are, you have the ability to set up different capabilities for the roles, and down to the granularity of individual REST calls. You can say that in our reader role, we want the readers to be able to set tags. Normally, unless you have editor role, you cannot set tags on a model or a model version. But you can make changes like that. You can customize for your requirements. So here's how authorization between users and groups work. When a user creates an experiment, the user gets manager role, and group members get editor role. And this is to enable other group members to create runs in that experiment and add runs, whatnot, because they're working together collaboratively. When a user creates a model, the user gets manager role versus group members get only reader role. Again, these are configurable, as I will show in my demonstration right next, but these are what we find to be useful defaults. Now, in this demo, we'll look at model creation and setting permissions. Here we are. We have a set of experiments, and I'm going to start by creating a model, and I can hit create model, supply a name for the model. And what this does is there is a model created by this name, but there are no versions for the model registered yet. That happens when you go back to your experiment section and look up a particular experiment that produced a model. In this case, I ran a XGBoost example again, and it produced a model. I can click on register model there, choose the newly created model and register it as a version in that particular model. So this gives us the ability to create models and register versions for that model. In this next demo, what I'm going to show is I'm going to add a specific permission for one of the models. I'm going to go to model created by SAML2. And if I pull the drop down by the model name, there's a permissions here. Group B is what SAML2 test belongs to. So that group already has reader permission, as I mentioned before. Here, I'm going to add a username infantstore-corp_jagain@infantstore.com and offer this particular user reader role for the model as well. Now you can also do groups. And the overall effect is that you have fine-grained control over how model authorization works. Right. There are a couple more things that I'd like to talk about before we open it up for questions and answers. The first is service high availability. If you have a service that you deploy to all the data scientists in your enterprise and you manage the permissions and the authorization and the authentication, it becomes critical that the service is up all the time. Imagine if your data scientists come in one morning and they run their experiments and it throws Python exceptions because the service is down. You could have a huge amount of lost productivity because the MLflow service was down. That is simply not acceptable. Those of you in the DevOps world and in enterprise applications world know that critical services like these are essential for the data scientists to do their day-to-day work. How do we address high availability in our system? When I talk about high availability, I'm talking about dealing with failures within a specific region, say US East 1. In the next slide, I'll talk about disaster recovery. That is recovering from the loss of an entire region. Let's say it got flooded and US East 1 is completely down. That would make headlines, of course, but it has happened. It has happened. I think Sandy was when that happened, but that is disaster recovery. In this case, MLflow service high availability within a region. So the data is stored in DynamoDB, as I mentioned, and DynamoDB by default has 3 availability zone availability. In other words, when we make an entry to the DynamoDB table, there are 3 copies of that data in 3 different availability zones. And failover is taken care of automatically. So if one of the AZs, one of the data centers basically were to go down, one of the other 2 would take over and service would be uninterrupted. And this is a system that is tested at scale by Amazon and it works very well. The REST API lambdas, what about those? Those lambdas are also deployed in 3 different regions, 3 different availability zones, and failure of one or more availability zones will not cause an interruption in service. You will have your MLflow service continuously available. The static JavaScript and HTML files are fronted by a CloudFront distribution that's global in nature, so that will also be available no matter what. So that brings us to disaster recovery. High availability is a very well solved problem and it's completely automated. You will not have to do anything administratively to take care of failures of availability zones. Disaster recovery, on the other hand, is a solved problem in our system, but there is a manual step. You need to perform a couple of steps manually in order to make the service available in a second region. Let's say that this is the architecture and a complete region goes out. Now, because CloudFront is globally distributed CDN, the static HTML and JavaScript are still available. If we use global tables, and that's what we recommend for users who desire disaster recovery, we can generate the table in the backup region. that table will be available modulo some loss where the transaction log may not have been transferred, but that's very minor loss given the bandwidth that Amazon has between availability zones. Now, the Lambdas themselves, we supply those as CloudFormation templates if you want to install them. So bringing those up for a disaster recovery process is about 5 minutes work, and the Lambdas will be up and running, pointing to the backup database. And finally, one more point is you need to make DNS entries that point to the new API gateway. Once that new DNS entries kick in 15 minutes or so, you should have a complete functional, close to how it was just before the region went down, service available within 30 minutes or so. So that's the nature of disaster recovery that we offer as part of our service. Thank you all for attending and watching through to the end. From myself and from Jitendra, I appreciate that. Let's open it up for questions. So the question we have here is from Dhaval Shah. How do you provide links back to the script or notebook responsible for creating the run or model? There are two ways. First, if the notebook is stored in Git, we store a reference to that particular hash of the Git, so you can go back to the source code. The second way is if you're running it as part of our Instance Store compute engine, we actually can grab the source code from the Git repository and store it as part of the artifact. So it's in the S3 bucket. Both of those options are present, and for historic reasons, both are valuable. If you click on a link, it'll take you back to the Git repo where the source code is stored. In other words, we do either Git or store it in S3 buckets. That's the short answer. Another question from a gentleman, I hope I don't mispronounce his name, Natu Lavchande, is thanks for the presentation. In which AWS region is the service available? The service is available in any region of your choice. It's actually a multi-region, multi-cloud service. We're focusing simply on the AWS aspects of it, but we have support for compute on Azure and Google as well. The short answer to your question is it's available in any region that you choose to install. We can install in your AWS account, or you can purchase it as a software as a service subscription. The SaaS version runs in US East 1. If you install in your AWS account, you can choose the region and install it there. Okay, I think that's it for questions. Thank you all for attending. Really appreciate it. Send your contact information to Aditya at infantstore.com. He'll have his email on the chat window. If you want the mug, the tumbler is the Yeti tumbler. It's a nice tumbler. We love that tumbler. So please do get in touch with us. And if you have any other questions about MLflow in general, we will let you know when the recording is going to be shared, and reach out to us if you have MLflow questions, if you have MLflow issues. You know, we're happy participants in the MLflow community. So if there's something we can help you with, even if it's got nothing, if it doesn't have anything to do with our product, we're happy to do that. And finally, if you want to try out our software, get in touch with us. We'll facilitate that. All right.
Okay, thank you all. Hope you have a great day, and we'll send you the recording soon.
All right, thanks, guys.